Pretty warm and good. Okay, glad for both.
Yeah.
Can't argue with that. Pretty warm and good.
I told you I was gonna fail it. I don't know why you. I showed you my answer. Like you said when it was like a. What is this? Was it two things? See, 8 out of 15. I only thought it was more. What you said, 8 out of 15? Yeah. Is it really that deep? No, it's okay. I just feel that.
Good morning, ladies and gentlemen. How are we doing today? Beautiful, beautiful, beautiful. Put away your phones. Put away your electronics, your headphones. Take out your computers and get logged in. We've got a lab to do today that's going to take us today and into tomorrow. We want to give you a chance to get as much of it done as you can, and I need your undivided attention as we're going through what we're talking about with the lab so that you don't get hurt today. Okay? So, get your computers out. The lab is in the notebook or in the Google Classroom, I should say. Please find it. It is the Chemical Properties Lab, ladies and gentlemen. All righty. All right. Okay. All right. Something else to keep in mind, ladies and gentlemen. Next week on Thursday, I believe that is your Unit 2 test. Okay? So your Unit 2 test will be next week, Thursday, ladies and gentlemen. We will spend next week, we'll finish up what we need to. Chemical and physical properties are one of the last few things. There is a little bit more. But then next week, remember, we're off on Monday. Tuesday, we'll finish up the unit. Wednesday, we'll do a little bit of reviewing. And Thursday, we will take the test. That is the plan, at least, ladies and gentlemen. Tomorrow is the last day for retakes for Unit 1. If anyone wanted to do it, remember, you need to bring me your corrections to the Unit 1 test. And then you can do the retakes. They will be around tomorrow after school since it is parent-teacher conference night. All right. What's the difference between a property and a change?
A property is the ability to a change is doing.
Okay. Property is a prediction. It's a characteristic. It's a trait. It describes something. Okay? It describes something. It is not an action. It is a description of what could, what would, or what will happen, depending on what you do, ladies and gentlemen. Okay? So that is what a property is. A change is an action. Okay? Now, please remember, if something can burn, let's go back a second. If it is burning, that means that it must have the property of being what? Flammable. So properties and changes do go together. If something will change, that means the property is that it can react with that substance, that it can burn. Okay? Keep that in mind when you are doing your lab today. We are going to be looking at chemical changes. And again, what are some signs of a chemical change? What's one sign that a chemical change has occurred? A gas is released. What's another sign that a chemical change has occurred? Unexpected color change. What's another sign that a chemical change has occurred? A precipitate settling out to the bottom. And the last sign of a chemical change? A change in energy. And if a change happens when we mix two things together, ladies and gentlemen, That means the property was that those two things would react. And that is what we are after today. We are looking for changes to be able to predict the properties. Okay? So keep that in mind. Changes are the actions. Changes are when things happen. Okay? But those changes mean that the property was that these two things would react together. Or maybe these two things won't. That is a property as well. These two chemicals, when you mix them together, nothing happens. That's a chemical property, as much as it is if two things will react. Okay? So keep that in mind. So today you're going to be able to identify chemical and physical properties that matter. More specifically, looking at chemical today. Okay? Chemical today. So let's open up our lab and let's take a look at it, ladies and gentlemen. All right. In Google Classroom, this is the lab, ladies and gentlemen. Now, there are actually 3 parts to the lab that we are going to do today. You're going to get the first 2 parts done today. Part 3 will not get done until tomorrow. Okay? After each part, there is a conclusion that you will be able to do. Okay? And that conclusion will talk about chemical properties. So, did the things in this part of the lab, did they or will they react together? And you're going to know that by if they did react together. Okay? Now, very important today, ladies and gentlemen. Tara, please put that away because I need your attention while we're going through this because I don't want you to get hurt today. This, ladies and gentlemen, is sulfuric acid. This sulfuric acid is as strong as you are going to get. It came right out of the bottle. So today when you are working with this, do not pick this up off the table. I don't want there to be a chance to drop it. There is one that is literally sitting right next to your test tubes. If you get this on your skin, it will burn your skin severely. If you get this in your eyes, there's a chance you will never see again. So keep your goggles on. Be careful. And that includes when you are cleaning up afterwards. When you are cleaning up afterwards, things can still go wrong and things can still get in your eyes. So if you take your goggles off because you went to the sink to rinse things down the sink, it is going to take and put you at risk. Please do not do that. From the time you go into the lab until the time you leave the lab, you are going to wear your safety goggles today. If you did not get a pair of safety goggles the other day, I still have them here. You can come up, you can take a pair of goggles, I will write your name down, send it to the office, and they will add it to your school fees. Okay? So, real quickly, in part 1, oh, by the way, the lab is set up to do 2 parts. One part, we use sulfuric acid with some powdered solids, with sugar, with salt, and with a substance called potassium chlorate. The other part, we're using hydrochloric acid with 3 different metals, copper, zinc, and magnesium. To make it so that you do not accidentally confuse the parts of the lab, this half of the room over here, this half back here, is set up to do the second part of the lab. This part over here is set up to do the first part of the lab. It doesn't matter which one you do first, which one you do second. You've got to get through both parts today. So when you go in back, half the class will go to one side, half the class will go to the other. When you finish on one side, you'll simply take your computers, move over to the other, and do the other side. That way there is no chance that you will accidentally mix 2 of the wrong things together. Okay? That is the way that it is set up so that you don't make mistakes. Now, in the lab, ladies and gentlemen, you also have to rely on all qualitative observations. There is nothing quantitative about today. We are not measuring heats. We are not measuring masses. We're not measuring volumes. None of those things. Everything is qualitative. Now, that doesn't mean that you can't feel the test tube to detect if there is heat being given off. You can, okay? But again, while you are doing the experiments, make sure everything is sitting on the counter. There is no reason to be picking things up. But there is also never a reason for you to put your head over a test tube and look down in it. Okay? Do not do that, because if something comes spitting up, it's going to spit up at your face. And even if the goggles will protect your eyes, if you get acid on your skin, it will burn it. Okay? I have a 3-year safety record of nobody being dismembered or seriously injured. I'd like to keep that going.
3 years.
3 years. What don't you understand about that?
So what happened?
I can't tell you there's still litigation pending. I'm kidding. Okay? I'm kidding. Okay? So let's not have an incident. Okay. The purpose of this lab is to identify chemical properties of different solids with acids or heat. Okay? Part 1, you are going to work with 3 what are called powdered solids. So you're going to work with sugar, you're going to work with salt, and you're going to work with something called potassium chlorate. Okay? Those are the things that you are going to work with. All right? Hang on just a second here. What I have set up here, ladies and gentlemen, is what you will find at your lab station. The sugar is in tiny packets, just like you would get at a restaurant, okay? So it's in there. Opening one packet will probably be enough for you and the group next to you. If you open a packet and you don't use it all, please just leave it sitting in the tray. If you throw it away, you throw it away. They're cheap. Salt is labeled salt at your station. So in the front of this weighing boat, this white powdered solid, it says salt. Please be careful because the other powder is a white powdered solid and it is labeled KClO3. KClO3 is potassium chlorate, ladies and gentlemen. Okay? So KClO3 is the potassium chlorate. You're going to take and make observations of all 3 of these powdered solids. Now, please remember, again, some of your observations may be the same. They may all be the same color. You can feel them. You can touch them. Okay? Do not touch the acids. You can feel them. You can touch them. You can detect if there is an odor. Don't taste anything today. Even though it's sugar and salt, please don't taste it. Okay? So, you're then going to take and you're going to put a small amount of each into a test tube. So you're going to take the salt, ladies and gentlemen, and you're just going to put a little bit on the edge of your spoon here. And you're going to take and you're going to put that into your test tube and try to get it down into the bottom. That is all you need, is just a small amount in there. Okay? A small amount in there. Now, one of the things, do not cross-contaminate, especially with the powdered solids. With the metals, it's a little bit harder to, okay? But with the powdered solids, you need to, when you are done using one powdered solid with your spoon, you need to wipe it off so that you can go to the next. So you'll take and just grab a paper towel, wipe it off really good, go to your next solid, put it in your next test tube. Now, I don't care. If you want to do one thing at a time, that is absolutely a great idea. If you want to put all 3 in the test tubes and then add the acid one at a time, that is your choice. But you need to make sure you know what is in what test tube so that you know which things are reacting. Okay? So again, in here, you're going to take at least 3 observations. 4 is recommended, but at least 3 observations of the sugar, of the salt, of the potassium chlorate, and of the sulfuric acid. Those are all on that side of the room. Okay? You're then going to, after you add a small spatula full of the salt to the test tubes and potassium chlorate and sugar to the 3 test tubes, you're going to add about 1 milliliter of sulfuric acid. Now, these pipettes, ladies and gentlemen, have 4 different marks on them all the way up. You will see that when you get closer to them. The one that is at the top here, right before the large part of the bulb, that is the 1 milliliter mark. Now, it does not have to be exact, but you want to put in about 1 milliliter in with the substance and see if it reacts. So you're going to take and you're going to put it in. Now, some reactions happen very quickly, some do not. Yes? Hurry up. Okay? So, again, you're going to see certain things happening. You're going to write down in the bottom what you see happen when you mix the 2 things together. It is very possible that nothing will happen. Okay? And if nothing happens, you simply, in one of these boxes, write down that there is no reaction. Nothing happened. But if something does happen, you need to write down 3 things to describe what happened. Now, please remember, odor, sound, okay? What you see, do not feel anything after you add the acid. So feeling and tasting are off the table after you add the acid, okay? Now, again, I didn't put a set out for you, but I would recommend doing this, ladies and gentlemen. In your tools, but not in mine, apparently. You will find a test tube holder. Let me go grab one, please, because I don't have one up here, apparently, ladies and gentlemen. I don't have one out at your station, but they are in the drawer marked student lab equipment or lab equipment. Test tube holders, ladies and gentlemen, look like this. Okay? So, you can put a test tube holder onto this to allow you to feel the bottom to notice if any heat is produced. When you are doing this, please do not point this at your teammate. Do not point this at the teammates across from you. Strange things happen, and sometimes things come flying out of test tubes. I don't want to see it flying into anybody's face. Okay? Now again, if there's no heat, fine. Okay? But if there is, you can record it. Okay? You're going to do that for all 3 of the acids with the sugar, with the salt, and with the potassium chlorate. Okay? Once you are done with this side of the experiment, then you're going to move over to the other side. Okay? Now, when you go to clean up, here's what I will tell you. Sometimes all of the acid that you put in there does not react. And if it doesn't, some acids do not play well with water. But we need to use water to clean up the test tubes. So you'll put the test tube holder onto your test tube. You will go over to the sink, ladies and gentlemen. Do not put the test tube underneath and turn the water on. Why? My sinks, some of them have a very hard time turning on. So when you turn them on, you have to use quite a bit of force sometimes. So it will go from off to that. And if it goes from off to this and you have a test tube underneath, the water is going to go into the test tube and it's going to come shooting back up at you. You want to get the water adjusted so that there is just a small stream of water. Again, I'm not going to point this at anybody. I'm going to take, and you can see it smoking in there. Why? Because that's unreacted sulfuric acid that did not react. And you're going to take and you're going to clean this up and you're going to pour everything down the drain with plenty of extra water. And what you're going to do is you are going to rinse this out 4 or 5 times until everything comes out. When you are done with this, ladies and gentlemen, you can put it upside down on your test tube holder. Okay? Upside down on your test tube holder. All right? Hadn't thought about this. I will put out extra test tubes because after they are, I don't want you reusing wet test tubes. Do not reuse wet test tubes. Come over to me so when you switch sides, ladies and gentlemen, if I do not get there first, come to me and I will give you 3 new test tubes to use. Okay? Do not use the ones that somebody else washed out. All right? Questions? All right. Cynthia, Nadia. You got to stay with me. I do not want to see you get hurt today. Okay? Yes.
Is there a charging like thing?
I will have to go get one in just a minute. Hang on. Okay? All right. So that is what you do on that side of the lab, ladies and gentlemen. Again, if you get to a station and the 3 test tubes are sitting in the rack drying, do not use them. I will bring you 3 new ones for you to use. Okay? I will bring you 3 new ones for you to use. On the other side of the room, ladies and gentlemen, is part 2 of the lab. Part 2 of the lab is almost identical to part 1. Oh, by the way, here's your conclusion. Using the changes in physical properties and the observations made during the experiment, determine which crystalline solids reacted with which acids, and then describe the chemical properties of each solid with sulfuric acid. So you're going to tell me the property of sugar is that it does or does not react with sulfuric acid. And then why? Why is it that it does react? Well, because when they mixed the two together, it gave off heat. It gave off a gas. It did this. So you are using the changes that you see to tell the properties. So in your conclusion, you are going to tell me, does salt react with sulfuric acid? Does sugar react with sulfuric acid? Does potassium chlorate react with sulfuric acid? You do not have to do this until after you get the other part done. Okay? But this should be able to get done today. All right? Second part. Now you're going to be on this side of the lab. Now I've got 3 different metals and I've got a different acid. So now we've got this hydrochloric acid. Now again, the hydrochloric acid is strong enough to seriously burn you. Not quite as strong as sulfuric, but strong enough to seriously burn you. So please be careful with it. Again, there is absolutely no reason for you to pick these things up and hand them to another group across the table. They have their own acid sitting by their test tubes. Okay? Absolutely no reason. Don't take it off of one table and move it to another. I want no chances of you spilling this stuff. I want no chances of you dropping this stuff. Okay? The metals are copper, zinc, and magnesium. So again, you start out by taking observations. You could touch the metals, you can smell the metals, you can observe the metals, do not taste the metals. And again, you need to take observations of the hydrochloric acid. You can smell the acid, you can take and look at it, you can listen, nothing's going to talk to you. Do not taste, do not touch. Okay? Then you're going to do the same thing. Now again, on this side, because they're metals, they probably will come off the spoon easier. They will not stick to it like some of the powders do. But again, it would be a good idea to clean it off. So you're going to take some of the metal, just a little bit on your scoop, and you're going to put it into your test tube. Then you're going to take your hydrochloric acid, and again, you're going to add about 1 milliliter of it. Squirt it right down into the bottom. Observe what happens. Okay? Observe what happens. So again, this part gets filled out first. Then down here, you're going to observe what happens in each reaction, ladies and gentlemen. If nothing happens, you write down that nothing happened. If there is a reaction, write down three things that happened during the reaction. Okay? And then, ladies and gentlemen, after this, you will write your conclusion. Now, because the powders are salt, they're sugar, and they're potassium chlorate, they can go down the drains. The metals cannot. Okay? The metals cannot go down the drains in our sinks. So in the middle section back here, ladies and gentlemen, I have 2 waste containers for you. One that is marked for copper and the hydrochloric acid. So you will bring your test tube over that has the copper and the hydrochloric acid in it, and you will dump it in this waste container. Please do not mix the waste. The copper goes in the one with the strainer on the top. The zinc and magnesium waste go in this container, and it is clearly labeled on the bottle which wastes go in which one. There is water already in the bottom of these to dilute what you put in here. So please make sure you put it in the right container. You can then go back to your station. You can rinse out your test tubes again, just like you did before. Turn the water on first, get it to where you want it. Rinse your test tube 3 or 4 times. Leave it sitting upside down on your test tube rack. Okay? Sitting upside down on your test tube rack. I will get new test tubes for you when you switch sides. There are 5 stations on each side. 6, 15. So we are going to use probably 4 of the stations on each side. So that means if you get done first on one side, there should still be a station for you to go to on the other side. And then someone would switch back. If 2 people get done on one side before someone's finished on the other, I'm sorry, you're going to have to wait. Okay? You're going to have to wait a minute. So I have 5 stations set up. I need to put things back on the end station here, ladies and gentlemen, because some of my stuff from here came from there. Your job today, ladies and gentlemen, is to get parts 1 and 2 done. And if you can get the conclusions done, do the conclusions. If not, there will be time tomorrow. You cannot do part 3. Part 3 involves heating of sugar and salt. I do not have the Bunsen burners out for you. We will do that tomorrow. Okay? Questions? There are lab aprons in the back of the room. If you want to put them on, because if you do spill acid, I don't know how, but if you do spill acid on your clothing, it will eat a hole in them. Okay? Also, again, goggles on the entire time you are in the lab. If you need to take your goggles off for some reason, come out of the lab toward the front of the room. Take them off, let your eyes breathe for a second, and then put them back on and go back to work. So we have now 16 people, so that means we have 8 groups of 2, ladies and gentlemen. I would like 4 groups to go to this side of the room, 4 groups to go to that side. That way, if you need to switch, there's a station open on each side. Your goggles are back there in the box, ladies and gentlemen, if you already bought them from me. If not, you need to come and get a pair from me.